Now in this lecture, I will add a web controller component to add an API to our service, Elastic Query Service. Let's first add the Lombok dependency in the PAM.xml file, as it is required to use in request and response models. Alright, first I will add a package model and create two classes: Elastic Query Service Request Model and Elastic Query Service Response Model. These classes will be used as request and response objects in REST calls in our API. Here you see 4 annotations, all from Lombok. We know these data and builder annotations, where data annotation creates methods like getter and setters and hashcode and toString, and builder annotation constructs a builder to create an object using builder pattern. Here I also added 2 new Lombok annotations, noargs and allargs constructor. Noargs constructor is required by Spring to create an object while deserializing JSON in HTTP request body. Because during deserialization of JSON to Java, Spring needs to create the Java object first with the default noargument constructor and then populate it with the values in the JSON. Here I also need allargs constructor to be able to use builder annotation, because builder requires allargs constructor by default. But since we are required to put noargs constructor, our application will not compile without putting an explicit allargs constructor here. That's why I need to provide an allargs constructor also here. Now I will add only ID and text to request model, as I only want to query with these fields. So I will create string, ID and text fields. But for response model, I will define all the variables defined in Elasticsearch, because I will return all fields in the response. So I define ID, user ID, text and created fields here in the response model. Let's then add a package API and then add Elastic Document Controller class, which will be the class that I will write our REST API. I will annotate this class with REST controller annotation. This annotation is a special controller annotation, and it includes response body annotation and simplifies coding. I will still put the response body annotation for the methods to show the usage here. But keep in mind that you don't need to put response body annotation in case you use REST controller annotation on the class level. I also need to add request mapping annotation to specify the base path in class level. And I will set the path as /documents. Let's now add a log variable first. I will use logger factory getLogger methods to get a logger. Then I will add the controller methods. First method will be getAllDocuments method. It will return a list of Elastic Query Service response model. I will wrap it with response entity, and then use response body annotation to automatically serialize response into JSON in the HTTP response. Although, as I mentioned, it is not required here, since I used REST controller annotation, I still added the response body annotation here to show how to use it in your code. I will use getMapping annotation for this method. That means it will use an HTTP GET method, and I won't add any URI here, so it will be called directly with the base path, which is /documents. For now, let's return an empty list from this method. And I will wrap the response object with response entity with 200 status code. And before that, I will log an info message. Please note that this response entity OK method will set the HTTP status code as 200. Second method is getDocumentById. The response is now a single Elastic Query Service response model object. Again, I will wrap the response model object with response entity. I will again use getMapping here, but this time I will specify a path variable for ID using parentheses surrounding ID. That means this endpoint will be called with /documents/ID replacement. So I need to define a string ID parameter here. Then I can use this ID inside the method. Let's create and return a response object by populating it with the ID specified in the path variable. I will log a message and return using response entity OK method, passing the response object to the OK method as a parameter. I will log a message again before returning from this method. As you see, I just create a mock object and return it. In the coming lectures, we will return a true response model object from Elasticsearch. But for now, I just created a dummy object here. Finally, in the getDocumentByText method, I will return a list of Elastic Query Service response model. Again, the response object is wrapped with response entity as you see here. For mapping, this time I use post mapping and specify a path getDocumentByText using dashes. So the final path for this endpoint will be /documents/getDocumentByText. Since this is a post mapping, I can use a request body, and I will do this using a request body annotation and use a parameter with type Elastic Query Service request model. Request body annotation is used to deserialize the JSON in HTTP requests to an object of Elastic Query Service request model automatically. I can then use this parameter inside this method. I will set the text fields into this Elastic Query Service request model parameter to query the Elasticsearch by text. I could also use a path variable again here, but I would like to show creating a post mapping and use request body annotation. I will create a list that includes the text fields in request body and return 200 response code again with response entity OK method. And before returning from these methods, again I will log an info message. I can now commit the config server repository changes and run the config server. So let's open a terminal window and run git add .command and then run git commit -am command to commit the changes. After that, I can run Elastic Query Service. So I will first run config server and then run the Elastic Query Service. After that, I can call the new API from Postman and see the mock responses. And also I can check the logs of our new microservice, Elastic Query Service. However, when I first call this API from Postman, I will see an unauthorized error. This is because I have the starter security in dependencies, which is required to use authentication with config server. And by just adding this dependency, it will also add security to our service automatically. So I need to add a security configuration. Let's do that. I will create a new class Web Security Config under config package in Elastic Query Service. I will mark this Web Security Config class with configuration annotation, so it will be a Spring Managed bean. Then I will extend Web Security Configurer Adapter class and also add enable web security annotation. This annotation and the web security configurer adapter class will allow me to add security logic in this class. Now I will override the methods from web security configurer adapter. I will override the configure method with HTTP security parameter. Now, one way would be to allow all paths by default and bypass the authentication. Let's try that. So in the overwritten configure method with HTTP security parameter, I allow all paths using AND matchers. As you see, I used permit all methods. Now if I run this service, it should work, because I allowed all paths using /** and I used permit all methods. Yes, it worked, but here I bypassed all the authentication. Although I will add OAuth and OpenID Connect protocols for security in the later sections, still I would like to add at least a basic authentication here. So let's update these methods and apply basic authentication. I will configure HTTP basic authentication and authorize all requests with the role user. Then I will also disable CSRF here, where CSRF stands for Cross-Site Request Forgery, also known as session writing. It is an attack that forces the end user of a web application to do an unwanted action in which they are already authenticated, but it requires a browser interaction to be effective. And CSRF protection will add a token to request to be sent from browser to server. In case there is no browser interaction, as in our REST API, we can disable it and remove one of the filters that Spring Security provides. Then in the configure methods with parameter authentication manager builder, I will set hard-coded user, password, and role. So I will use in-memory authentication methods on the authentication manager builder class and use with user, password, and roles methods to set user, password, and the roles. And for role, I need to set user role, which is required in the configure methods, as you see in the above method. For now, I will run the application using this hard-coded user and password and the role, but stay tuned, I will still update this to externalize user information and use an encoder for the password. Here I set no option to use the password as plain text. And although this is temporary, it doesn't look good. So let's run the application again. This time I get an unauthorized error. Let's use the authorization tab. And in the Postman, I will set the basic authentication credentials. Then it worked. If you check the request at this point, I see that an authorization header is added to the request, and username and password are sent by encoding them using base64 encoding. Now please stop the video and add a user config data configuration class with user config configuration prefix and add username, password, and roles as properties. Also, update the query service YAML file under config server repository and set the password by encrypting it using Spring command line utility. Then update the security config to inject and use user config data that you created. Then please try to run your service again. Alright, I hope you worked on this task. Now let's do the changes together. First, I want to create a user config data class in appconfig data module. Please stop the config server also at this point, as we will now work on configuration, and config server will need to restart after that to get the new configuration values. I set the prefix as user-config here, and I create username and password as string and roles as string array. Now I will update the service configuration in config server repository and add user information here. Normally, I would like to get the user information from a persistent store or from LDAP, but for simplicity, I will use configuration file to set them. Because we will use this authentication mechanism for now here, but I will replace it with OAuth and OpenID Connect protocols in the coming lectures. As you know, I have already a solution for encryption, and I can use Java cryptography extension for that. So let's encrypt this password using the Spring command line utility. If you don't remember your key, you can look for it using echo $encrypt_key command. It should be there if you have followed the previous sections. After getting the encrypted password, let's update the config file and commit and push the changes. Now I can use the user_config data class in security config class by injecting it. Then I update the in-memory authentication configuration by reading the user information from the user_config data object instead of hardcoding them. And then let's try to run the application again. First I will run config server and then the query service. Then I will try to call the API from Postman. Alright, we get an authorization error here. Let's check the logs. Okay, it says that there is no password encoder specified. Remember, I have used no-op for plain text. But I want to specify a password encoder instead, because in that case, I won't hold the plain text password in memory, but only hold a hashed version and do the comparison with the hashed value with the user-provided password. It will be easy to add an encoder. Let's go to the security config and then add a bean called password encoder. I will use bcrypt password encoder class, which uses bcrypt strong hashing function. This is an adaptive function and use iteration count to increase difficulty against brute force attacks, in addition to using a salt to protect against rainbow table attacks. So let's use this bean to encode our password and rerun the application. I will use password encoder encode methods and send the password as parameter. Now if I run the API in the Postman, I got 200 OK response as you see. Let's try the other endpoints in our REST API. I will test the getById endpoint using documents/1. And then try getDocumentsByText endpoint by changing the HTTP method to post and also passing a request body as JSON to send the text. Great, it all seems to be working now. Great job so far. I will create service layer in the next lecture to make a call to the Elasticsearch. So I will see you in the next lecture.